Hey guys, this is Preston with the DLASC. I wanted to continue doing some Calculus 2 integrals today. This time we're going to be using the trigonometric substitution method. And I found a few special case problems that I think are fun to work. So we're going to go ahead and work some of these. First one is going to be integral of 1 over square root of 64 minus x squared. Now, for this video, I'm not going to prove how trig sub works or anything. I'm going to go ahead and assume that you guys are trying to figure that out on your own. I wanted to work some special case problems so that you can have some help while you're going through your homework. Hopefully your professor has provided you some sort of a formula sheet so you can start trying to recognize the patterns while you're studying. It's good to have a sheet right next to you that you can reference. But I'm just going to go ahead and jump right into it, okay? So here I see that I have this radical expression 64 minus x squared. I know that if I see a squared minus x squared, I know that sine times a is going to be equal to x. Sine theta times a is going to be equal to x, okay? And that's because we're going to go ahead and write this out. Sine theta equals x over a sine theta equals x. All right, and then this is going to be 8 sine theta is equal to x. Okay, now if all that is true, then I know that I'm going to have to sub for dx, right? So I'm going to have to differentiate cosine theta. Don't forget your d theta here, okay? Equals dx. All right. So now that I've gotten that far, I'm going to go ahead and draw this triangle. The way that I remember it is if I'm dealing with sine, the sine pattern here, right? If I'm dealing with that, then I know that if sine theta is equal to x, sine theta times a is equal to x. Okay, sine is opposite over hypotenuse. Okay, that helps me remember that x is always going to be on the opposite. Square root of 64, which is a, right? A is going to be here as the hypotenuse, and then whatever is left is going to be 64 minus x squared. It's going to be this adjacent side here, okay? Now, if I look back at my integral, I see that I'm going to have to substitute for that radical expression. Currently, I don't have that by itself in terms of x. I need to go ahead and get that. That's going to be pretty easy. I mean, adjacent over hypotenuse, that's going to be cosine theta, right? So cosine theta is going to be equal to the square root of 64 minus x squared over 8, like that. It's going to be 8 cosine theta is equal to the square root of 64 minus x squared. All right. Actually, I forgot to copy this down at the beginning of the problem. That makes it way more interesting. All right, so now let's go ahead and sub everything in, okay? This is going to be the integral. Dx is equal to 8 cosine theta d theta, all right? So I'm going to go ahead and write 8 cosine theta. Here in the numerator, I know my d theta is going to be off to the side like this, okay? And then down here, this is going to be 8 cosine theta cubed. Right? Okay, so let's just go ahead and start breaking it down. I'm going to go ahead and pull my constant out. Or actually, you know what? We'll just leave it in. We'll leave it in for now. But what I am going to do is I'm going to go ahead and cube my denominator. And I don't really care what this number is because I have an 8 in the numerator. You'll see what's going to happen. It's going to be cosine cubed theta, d theta, right? And then that is going to reduce to, I'm going to go ahead and pull it out, 1 over 8 squared, right? Which is 64 because we have an 8 in the numerator that cancels 1 8 in the denominator. And so we end up with 1 over 8 squared. Right, and that's just a constant, so I'm going to go ahead and pull it out. And then obviously, cosine over cosine cubed, you're going to have a cosine cancel in the numerator and the denominator, and we're going to end up with 1 over cosine squared theta d theta, which is equal to 1 over 64 times the integral of secant squared theta d theta, right? And then hopefully you can kind of see where we're going with this. Hopefully you know your integrals, okay? The integral of secant squared theta is tangent theta. So this ends up breaking down to 1/64 times, 1/64 times tangent theta. And of course, plus c. Okay, well, that's all great, but I needed my answer in terms of x. So this is where drawing the triangle at the beginning of your problem is going to come in real good use. Okay, because every time you need to put this back in terms of x, you're going to need to look at your triangle to figure out how you can express whatever trig function you're left with in your final solution. So for this particular one, well, tangent theta, this is going to be opposite over adjacent, right? So that's going to be x over the square root of 64 minus x squared dx. Okay. Well, that means that my final answer, we'll just go ahead and formally write this out. The integral of 1 over square root of 64 minus x squared cubed dx is equal to 1/64 times x over the square root of 64 minus x squared plus c. And there we go. That is integral number 1. Let's go ahead and do one more. Boom. All right. Okay, so this one is going to be the integral of x over 8 times the square root of 64 plus x squared dx. Okay, so for this one, again, hopefully in your notes, you have it recorded somewhere that the pattern square root of a squared plus x squared is going to be tangent, right? Okay, a times tangent is going to be equal to x, okay? So what we're going to do is just go ahead and write this out. Since we know that, we can say that tangent theta is equal to x over 8. So 8 tangent theta is equal to x. So 8, the derivative of tangent is secant squared. So this is going to be secant squared theta d theta. This is equal to dx. Okay, so now I'm going to go ahead and draw my triangle. And again, we're dealing with tangent. And I know that the x is in the numerator, and I know that tangent is opposite over adjacent, okay? So that means that my x is going to be opposite, my 8 is going to be adjacent, and then my radical expression is going to be right here at the hypotenuse. Okay, now I don't have an expression for the radical expression, right? So what I need to do is go ahead and note that, well, okay, so how do we go ahead and express this the way that we want to? Cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. If I use that, that's going to be this guy over this guy, right? And then if I multiply again by 8 to both sides, I'm going to end up with 8 secant theta is equal to my radical expression, right? Secant theta is going to be equal to 64 plus x squared over 8. So 8 secant theta is equal to the square root of 64 plus x squared, like that. Okay, cool. So now that I've got that, I'm going to go ahead and substitute everything back in. All right, so this is going to be the integral of, let's see, so x is going to be 8 tangent theta. That 8 is going to cancel, right? So this is going to end up being tangent theta times, that was 8 secant theta, right? And then dx is going to be secant squared theta d theta. Okay, so now I see something that I can do. Hopefully you can see it too. I'm going to rearrange this and then maybe you'll be able to see. Okay. Oh, I forgot my 8 here. All right. All right, so we're going to have, I'm going to go ahead and pull my 8 out. We're going to have 8 squared times the integral of secant squared theta. And I'm going to leave this out. I'm not going to make that secant cubed because the derivative of secant theta is secant theta tangent theta. So I see that I can do a quick little u sub here, right, where secant is going to be my u, secant squared is going to be my u. Okay, so if secant squared theta is going to be my u, then what I'm going to end up with is 8 squared times secant cubed theta over 3 plus c, right? All right, cool. So I'm going to pull my constant out. This is going to be 8 squared over 3 times secant cubed theta plus c, right? Okay, so that's going to be, let's just go ahead and make this 64 thirds, right? And then my secant theta was this radical expression over 8, right? So that's going to be square root of 64 plus x squared over 8, that whole expression cubed, plus c, right? And look, I'm going to do something fun just to simplify it. Now, this right here is a perfectly acceptable answer. Your professor most likely will not take points off on a test for an answer like this unless he specifically says to reduce it. So I'm going to go ahead and reduce it because I think it's fun and interesting. So what I'm going to do is I'm going to pull out, this is going to be 1 over 8 cubed times this, right? I can do that. Cubed plus c. Okay, well, this is going to cancel, right? And 2 8s are going to cancel because 64 is 8 squared, right? So we're going to have 1 over 8 times 3, which is 24, times, and I'm going to rewrite this too, 64 plus x squared to the 1/2 power to the 3rd power plus c, right? Well, if I can do that, then I can do this. And there you go. There's your final answer. All right, guys, I'm going to do one more video where I'm going to do a more interesting trig substitution problem. Hopefully you guys are enjoying these, and have a nice day.